electric field intensity due to a point charge. In case we have two charges, as shown in a diagram, Q and Q0, separated by distance of r. Then from the Coulomb's law, the force between these two charges will be 1 upon 4 pi epsilon 0 q into q0 upon r square. The value of 1 by 4 epsilon 0 is 9 into 10 to the power 9 Newton meter square per Coulomb square. Now since the formula for electric field intensity is force upon q0, as the electric field intensity is defined as the force experienced by a unit positive charge placed at any point inside the electric field. So we can write E is equal to F upon Q0, where F denotes the force experienced by the unit charge. By unit charge, we mean a charge of 1 coulomb. So on substituting the value of F, 1 upon 4 pi epsilon 0 q0 upon r square. In this equation, q0 cancel and we will get E is equal to 1 upon 4 pi epsilon 0 q upon r square. This is the formula for electric field due to a point charge. Electric dipole. What do we mean by an electric dipole? An electric dipole is a combination of two equal and opposite charges, say plus q and minus q, separated by a certain fixed distance, which can be assumed to be 2L. The dipole possesses a property known as the electric dipole moment, which is denoted by P. And this dipole moment is defined as the product of any of the charges, that is Q, and the distance between the two charges. So the formula for dipole moment P will be equal to Q into 2L, where Q is the charge and 2L is the distance. Since the charge is measured in coulomb and distance in meter, so the unit of electric dipole moment will be coulomb meter. And this is always a vector quantity. And the direction of the electric dipole moment is always from the negative charge to the positive charge.
Now our aim is to find the electric field intensity on the axial axis of an electric dipole. By axial axis we mean along the same axis of the dipole. So as shown in the diagram, we have two charges A and B. At the point A we have a charge plus Q. At the point B we have a charge minus Q. They are separated by distance of 2L and O is the midpoint of AB. Now we have taken a point P at which we want to find the electric field intensity due to this dipole AB. The distance of this point P from O is small r. So the distance AP can be written as equal to OP minus OA. So AP will become equal to R minus L. Similarly, the distance PB can be written as equal to PO plus OB. So that will become R plus L. We already know that the formula for electric field intensity due to a point charge is given by E is equal to 1 upon 4 pi epsilon 0 Q upon R square. The electric field intensity at the point P will be the vector sum of the electric field due to the charge A and that due to the charge B. Now the value of EA will be equal to 1 upon 4 pi epsilon 0 Q upon R minus L whole square. And this electric field intensity will be directed along AP because the electric field from a positive charge is always directed outwards. So we have written that it is directed along AP. Similarly, the electric field intensity at the point P due to the charge minus Q at B will be equal to EB is equal to 1 upon 4 pi epsilon 0 Q upon R plus L whole square. And this electric field will be directed along PB because electric field is always directed towards a negative charge. Now the net electric field E will be the vector sum of EA and EB. So we have written E is equal to vector E is equal to vector EA plus vector EB. If we want to write in terms of magnitude, since EA and EB are oppositely directed, so we can write E as equal to EA minus EB. Now if we substitute the values of EA and EB, is how much? 1 upon 4 pi epsilon 0 Q upon R minus L whole square. Similarly, EB is 1 upon 4 pi epsilon 0 Q upon R plus L whole square. So the value of E we have got 1 upon 4 pi epsilon 0 Q upon R minus L whole square minus 1 upon 4 pi epsilon 0 Q upon R plus L whole square. Now we can take Q upon 4 pi epsilon 0 common in both of these two terms. Now since Q upon 4 pi epsilon 0 is common in both the terms, we can write E is equal to Q upon 4 pi epsilon 0 bracket 1 upon R minus L whole square minus 1 upon R plus L whole square. On taking the LCM, we get E is equal to Q by 4 epsilon 0 bracket R plus L whole square minus R minus L whole square divided by R minus L whole square into R plus L whole square. Now we have a property A plus B whole square is A square plus B square plus 2AB. And we have another property A minus B whole square is A square plus B square minus 2AB. So using these two properties in the numerator, we will get E is equal to Q upon 4 pi epsilon 0 bracket R square plus L square plus 2RL minus, since there is a minus sign before R minus L whole square, so the sign of all the terms will be changed. So minus R square minus L square plus 2RL. And in the denominator we are having R minus L into R plus L. That can be written as R square minus L square. So in the denominator we will get bracket R square minus L square whole square. We have used the property A minus B into A plus B is equal to A square minus B square. So E will become equal to now Q upon 4 pi epsilon 0 R square plus L square are positive, and there is minus R square minus L square. So these two terms will cancel. So we have left with E is equal to Q upon 4 pi epsilon 0 bracket 4RL divided by R square minus L square whole square. Now since we have just seen previously that there is a quantity known as electric dipole moment, which is equal to 2 into Q into L. So we can break this Q into 4RL as 2 into Q into L into 2R. And we are writing the denominator as it is 4 pi epsilon 0 bracket R square minus L square whole square. So Q into 2L will become P. So we will get E is equal to 1 by 4 epsilon 0 2PR divided by R square minus L square whole square. So this is the formula for electric field intensity on the axial axis of an dipole. Now in case we want to find the electric field intensity at a point P, which is at a distance R, which is very large as compared to L, then we can neglect L in the denominator. So we will get E is equal to 1 by 4 epsilon 0 2PR divided by R to the power 4. Now 1 R will cancel, so we will get E is equal to 1 by 4 epsilon 0 2P upon R cube. So this is the formula for the electric field intensity due to a dipole on the axial axis for a short dipole.